Today, we are going to talk about the modular functions. So, if modulus of x, you can have two values. X is more than or equal to 0 or less than or equal to 0. Okay. In that case, for an example, if I say modulus of 2, the answer will be equal to 2. Similarly, if you have a negative value inside the modulus, that will be 3. Both will produce a positive value. It's an easy way to think. If you square the 2 and square root it and you get the answer 2. If you square a minus 3 and square root it, you will get 3. So this is all about the modular. You have to be careful. In future, we will be doing a lot of questions. For an example, if I have a graph similar to this one, it's a quadratic graph. In this case, if you want to draw the modulus value, is always reflect anything underneath the x-axis. So the graph will be exactly same as this. It comes from here. Okay. It will come from here. Then stop here. Only this part is, you can see this part. That is a beneath the x value. So that will be reflected. Then it goes like this. So this part, the beneath part will be reflected on the top. Then it will go on the like this. And here you can see this part will reflect like this. So this is the y equal to fx, and this one will be equal to y equal to modulus of fx. Okay. I hope you understand this. So only any part of the graph is beneath the x-axis will be reflected. So I can write this y equal to modulus of fx is a reflection of y equal to fx in the x-axis. It's a very important statement. So if you can try a few questions, that I got 3 questions here. Y equal to modulus of x plus 2. So we can simply draw a line. Okay. Simply y is equal to x plus 2 without modulus. So you can see, you can substitute y equal to 0 and x equal to 0. Then you will find the values of this is minus 2 and other ones 2. So as you know, if you read the statement, fx is a reflection of y in the x-axis. So only one part in here has to be reflected in this part. Therefore, the reflection will be equal to something like this. So this graph will be equal to that one. Then there's a quadratic graph here. This is a A part and that's a B part. That's A and that is a B and that is C. If you look at that, y equal to modulus of x minus 2 multiplied by x plus 1. Therefore, you can see it's a quadratic. So the graph will be something like this. That is an actual graph. It's not a modulus graph. So as I said to you before, this only reflects only these parts. Therefore, that's going to be something like this. Then something. It's going to come like this. So the graph will be like this. So this is going to be y equal to modulus x minus 2 and x plus 1. Now look at the graph. Y equal to natural log of ln x, that's a modulus 1. So we simply draw the normal one, y equal to ln x. So the graph will be like this. So only this part will be reflected. So that will go like this. Sorry, that graph is wrong. That should be graph. I think that graph is wrong. That goes something like that. Therefore, the new one will be equal to this part. So that part will come like this. Then it goes like this. So this is y equal to modulus of natural x ln x. So these are the three graphs. Then I'm going to do another question. This is a part 1 of this modulus function video. So if I do this question, we can see there's another question here. So any question is better if you can start with the best graphical solution method. So if you do that, you can see there is a question here, y equal to modulus of x plus 1. And this is, so if I wrote the question, modulus sorry, x plus 1 modulus minus 2x minus 5. If you look at this question, this is an easy question. You can see this is only one intersection here, this one. Therefore, the solution will be only one solution. So what we can do, we can look at these both graphs and where they intersect and what sort of graph they have. If you look at the y is equal to minus 2x minus 5, that graph, it is a negative gradient because the negative positive gradient always goes like this. The negative gradient is always going like that. So you can see that has a negative value. And also, if you look at the modulus graph, that is also has a negative gradient. Therefore, we don't have to use positive values. So if I use that, then in this case, I will use only the positive negative value. So minus x plus 1 minus x plus 1. And this one is already minus, so I'm not going to bother. Minus 2x minus 5, because that's not going to change, but that's a normal graph. So minus x minus 1 equal to minus 2x minus 5. So expand the bracket, that's going to be happen. Then x is equal to, you will see the answer, minus 4. Therefore, the answer is going to be minus. So the intersection will be only minus 4. So you can substitute this value into both of them. Then you will find the answer exactly the same. So for example, basically, if you substitute positive value, you're not going to get it. So we only can substitute the negative value. So that is going to be equal to minus x minus plus 1 times minus 2x minus 5. So you get the answer if you do that, x is equal to minus 4. So that's exactly, we have it there. So our answer is correct. Sorry, I made one mistake. If you like this video, please subscribe it. And also if you press the bell button, you will get our next video. I will be following this video, the second part. So thank you.